The broadcast is now starting. All attendees are in listen-only mode.
Welcome to a special webinar sponsored by the Workflow 4.0 e-newsletter and ClearEdge 3D. Our webinar topic today is the new EdgeWise 5.0, 4 major technology advancements for faster modeling. Hi, my name is Kevin Corbley, and I'll be your moderator today. And I'm the editor-in-chief of Workflow 4.0, the newsletter of 3D scanning, modeling, documentation, ideas, and opinions. And let me start by thanking you for joining us today. There's obviously a lot of enthusiasm out there to see the latest from EdgeWise. We have nearly 500 people registered. And today we will present the new EdgeWise 5.0 software, which is absolutely our most ambitious and technologically advanced release to date. And we'll also hear from 2 early beta users who have had a chance to put the software through its paces. And we're going to focus, actually, we say 4 advancements. We've actually got 5 for you today. And the ones we're going to be talking about are enhanced pipe extraction algorithms that virtually eliminate false positives. Also, auto extraction for gridded steel, and deeper integration with Revit, especially when it comes to non-standard features. And we've also got the Plant 3D plugin that lets you model in EdgeWise and then bring the model and associated intelligence into Plant 3D. And as a bonus, we're going to show you the new ClearView visualization engine that creates photorealistic representations of the point cloud. Let's take a quick look at today's agenda. We've got the intros and goals that I'm discussing right now, of course, and I'm going to hand it off pretty quickly over to Kevin Williams for the actual discussion of the EdgeWise 5.0 features and the first public demonstration. And then we'll have our first case study focusing on the enhanced pipe extraction. And our second case study is going to be focusing on the Plant 3D plugin. So we'll hear those in just a few minutes. And as always, we'll wrap up with a Q&A session with our experts. And let's run through a quick housekeeping detail here. Everyone is muted during the session except for the presenters, but we do encourage you to ask questions at any time, and you can do that via the question window. You should find that in the right-hand corner, lower right-hand corner of your screen. And we're going to take the Q&A at the end, but please feel free to send those in at any time during the presentation. And we are recording today's webinar, so you'll each receive a link shortly after the webinar ends. If you'd like to share that with your colleagues or watch again, you're welcome to do that. And just a quick reminder, subscribe to the Workflow 4.0 newsletter. We say that's a newsletter for sharing experiences, opinions, best practices, and we like to throw a few case studies in there as well. And I'd like to introduce our panelists today. We've got Chris Nixon, PLS, and he's the principal in Meridian 3D Inc., based in North Carolina, and he has a decade of precision survey and laser scanning experience. And we've also got Louis Boxer. He's the technical director at Advanced 3D Laser Solutions in the United Kingdom, and he has extensive experience in oil and gas as well as 3D modeling. And then there's also that familiar face there. Kevin Williams is the chief scientist at ClearEdge 3D, located in Virginia, and he founded ClearEdge 3D several years ago, and he's really a renowned expert in automated feature extraction technology. Gentlemen, we're happy to have all of you with us today. So what I'm going to do, we're going to jump right into this, and I'm going to ask Kevin Williams to come on, and he's going to take over here and give us that demo. Kevin, take it away.
All right. Well, thank you, Kevin Corbley. I'm excited to be here today talking about 5.0. And like Kevin alluded to earlier, I'm really quite excited that we have 5 things to show rather than just 4. Just a little bit of insight into the real lives of developers here at ClearEdge 3D, which probably ought to be a reality show at some time. A week ago weren't sure that we were going to have the automated extraction of patterned steel because it was, there's a lot to it. Very complex stuff, and it was all kind of up in the air. Well, 4 o'clock yesterday in the afternoon, we finally got it together enough to do a demo. So I'm really quite happy about that, because I think it impresses me. I think you guys will really enjoy this new functionality. I'm glad we can show it today. So the new release 5.0 is going to have a number of new upgrades, bug fixes, things like that, but the 5 things that are probably going to be the most standout-ish for you are going to be enhanced pipe extraction, automated extraction of pattern steel, better Revit integration, Plant 3D integration, and then the new visualization engine. And just to give credit where credit is due, we've been blessed with a number of really smart and creative customers, from whom we have shamelessly stolen some fantastic ideas. And I know a number of them are sitting in on this webinar, and so as the CTO of ClearEdge and the de facto product manager, I just want to express some gratitude and thank you guys for the help in designing this stuff. All of these major functions, all of the updates, most of the stuff that goes into EdgeWise originates with customers, and I really appreciate that. All right, so let me go through these in a little bit more detail. The first one, enhanced pipe extraction. We spend a lot of time improving the core extraction algorithms to the point where we nearly eliminate the false positives. If you've used the software in the past, you've probably seen things like what I'm showing in this slide here, where you've got a beveled corner on the edge of this concrete structure, and it shows up as a pipe because it fits really well to a cylinder. Those points do. Well, these new algorithms go through. They're a whole lot more robust against things like corrugated steel, beveled corners, stuff like that. And additionally, we're getting, because we're doing better point selection, we're also tending to get better fits to the good pipes even. So it's a whole lot better all the way around. And here's just a quick and dirty internal study that we did with a couple of our more egregious data sets from the past. We had a plant scan where the old software, there were 1,200 good cylinders, and there were almost 300 bad false positives. With the new algorithm, got that down to 28. In the mechanical room, this was one of the worst ones we ever processed. And you can see we got 659 false positives, almost as many false positives as legitimate cylinders. With the new algorithms, we got that down to 9. So it's not 100% perfect, and probably never will be, to be honest. But the amount of cleanup time is almost negligible now. We've really cut that back a lot. And we've also, in the upcoming release, it hasn't been available to the beta testers yet, but in the upcoming release, there's enhanced QA functionality that will let you go through and find those and get rid of most of those really quickly and easily as well. Next is the automated extraction of gridded steel. This has, in my mind, kind of an optimal blend of user guidance and automation, and it goes through and makes really quick work of repetitive steel patterns. And I'll demo this in a little bit. It's important to note that every single element here is individually fit to the point cloud, so it's not just a dumb array that you would get with a package that ignored the point cloud. It goes through and fits every element. We have improved our Revit integration substantially, even out of tolerance elbows. This functionality has been around for a couple of months in beta format, and it's going to be incorporated into 5.0. But this new functionality works really quite well, and we bring nearly 100% of elements across to Revit. About 1 or 2 out of 1,000 still get dropped, and we have detailed reporting now that shows exactly where that happens. So if egregiously weird geometries still may not come in, but we report where those failures are. And then finally, if you've ever noticed a slight mismatch between elbow sizes and the adjacent pipes, that's been addressed as well. Next is the Plant 3D plugin. We've had a number of people requesting to use our software for Plant 3D, and we've now got a plugin that brings this stuff in as fully intelligent models. And finally, this component has been around in a beta form for a release or two as well. The photorealistic visualization engine. We've also significantly enhanced the responsiveness when navigating through the point cloud. So it's a very fluid, very user-friendly way to navigate a point cloud and see what's going on inside the points. So with that, let me jump into a demo, and I'm going to start off with just a real quick overview of what the new import into Revit looks like. I'm going to do these in a slightly different order from what I showed in the slides, just because I can. So if it looks really similar to, it's the basic functionality is we would use EdgeWise to go through, automatically extract these pipes, catch any pipes that were missed, and complete the model, and then export to Revit using our Revit plugin. And of course, all of these objects come in as fully functional Revit objects. But if you've used EdgeWise in the past, you'll notice that all these elbows now come in. Whereas before we would drop a fair number of them if they were outside of Revit's tolerances. Our developers, our Revit developers, figured out a workaround to force Revit to accept really severe cutbacks and all in the pipe elbows. So that's should make life a whole lot easier for the MEP guys out there. Next is the Plant 3D plugin. And I'm not going to, it's nothing exciting about bringing these systems in. Probably the majority of you guys have seen the creation of pipes inside of EdgeWise. And I'll go over that just a little bit in the next part of this. But the idea is you build pipes inside of EdgeWise using the automated tools, and then you can directly export them as intelligent objects directly into Plant 3D. So if I zoom in here and click on any of these assets, you can see that this is a gate valve, 150-pound ASME spec. All of the intelligence from EdgeWise transfers directly over into Plant 3D through this new plugin. All right. Now let's get into the enhancements that are inside of EdgeWise. So here's just a small sample point cloud. I've turned the transparency on because that will allow us to see the underlying model once we start playing with those. Just a real quick overview of the clear view navigation. These little green spheres show all of the different scanner setups, and if I double click on one of them, I'm going to navigate to the point of view of that scanner, and then it looks like it loads in a photo-like point cloud database that I can start modeling from. I can also jump between these scanner locations, so if I double click on this other scanner location, I'll jump to it, see the world from that point of view, and I can seamlessly move in and out of the scanner views and full 3D just by double clicking on the green icons. back up a little bit and show you the results of the new pipe extraction algorithm. So these are the results of the old pipe extraction algorithm. You can see it does a great job of actually getting all of the vast majority of the existing pipes in this data set. But you can also see, if I zoom over here, you can see that this corrugated steel fit the pattern for a cylinder very, very well, and it mistakenly grabbed a whole bunch of corrugated ridges as if they were pipes. There's some more corrugated steel laying on the ground down here. It also caught the rounded, beveled edges of the concrete footers for these columns. And then over here I've got more corrugation. So you can see, although the software went through and grabbed a whole lot of useful information out of all the pipes, there's some significant cleanup left to do to go through and use the results. So with these new algorithms, let me turn on the new pipes. The green pipes were run using the new extraction algorithms. And you can see that it's virtually limited to real pipes. It does still pick up railing, just because the computer's not going to be smart enough to figure out that that's a railing versus pipe, at least not yet. So anything that's actually cylindrical and fits really well to a cylindrical pattern, it's going to pick up. So we would still have to clean those railings up, but most of the rest of the stuff, all the corrugation is gone, the beveled corners of concrete, etc. So the cleanup job is very, very minimal now. Let's talk about the new structural steel tools. There's a lot of good structural steel in this facility. We navigate to the back side of this. I've got a start at a model here. If you've never seen the structural modeling tools in EdgeWise before, the way it works is you would go through and delineate a section of the point cloud like this, and the software would go through, in this case, the AISC steel catalog, and find match the point cloud against all the different steel cross sections in that catalog, and find the best one and place that piece of steel for you. So you can see if I went through and modeled these out, it would take me a little bit of time, because there's 150 different elements here. So let me undo those and show you the way the new tool works. Starting with just 6 pieces of steel here, what we're going to do is we're going to look for patterns. And so I want to select these 2 bottom pieces of steel, and I want to find the pattern all the way up. So let me zoom out just a little bit and use this pattern extraction. So I'm going to copy the 2 selected pieces of steel, and I'm going to give it 2 seed points to go off and find the pattern. So you can see it just created 5 new elements for me. And it's important to note, it didn't just copy and array these elements. It went through and analyzed the point cloud and fit these elements. If it found a fit, it fit those elements into place. So these are very well positioned, tied up against optimized fit to the point cloud. Let me do this 2 more times. I'm going to select these and look for the pattern going off in this direction. And keep in mind, this is crunching through, tens of millions of points and fitting this. So it's going to take 30 seconds or so to go through and find all of the elements. This is new enough we don't have a progress bar either, so you have to watch the little spinning blue icon. There we go. So there you can see the pieces of steel that it found following that pattern. And a couple things to note. Let me zoom in here and just kind of show you what it actually did. So if you look at my original pattern, let me flip it this way so it's a little more clear. This I-beam, the eye was horizontal on the screen. When it found this next one over, the pattern didn't quite follow. The I-beam over here is vertical oriented to the screen. And so it did a refit and placed the correct orientation of the beam into place. Same thing with actually the rest of these. One other thing to note, it's not perfect yet. We're still refining this. It'll get better by the time of the actual release, but you can tell we missed a beam here, so I'm going to go in and just extract this. Whoops, extract this beam here. There we go. Now I'm going to do one more search of the point cloud. I'm going to grab this entire face, and I want to do a search in the opposite direction. So I'm going to use my pattern extraction tool, give it a seed direction, and let it go off and find as much of the remaining steel as it can that follows this pattern. I thought this was a really quite clever interface for doing this procedure. John Sloan, our VP of software development, came up with this, and I didn't quite understand the interface he was describing at first, but once he put it together and he showed it to me yesterday, actually, I was blown away. It's a really cool, quick, and easy way to be able to model steel like this. I think it'll work really well for a lot of different projects. Steel tends to be very, very gridded in nature, very patterned, and this tool makes the job of finding all of that really quick and easy. So here, let me turn the point cloud off. You can see all the pieces of steel that the software found and fit into place. And again, every single piece is actually custom fit to the point cloud, so it's extremely accurate. These are true as-built pieces. They're not simply copied or arrayed pieces of steel. It looks like I missed one other piece of steel in here. So anyway, big time savings. I believe have I lost the control?
Let's see, you should still be presenter, Kevin.
Are you still seeing my screen?
I am not seeing your screen right now.
All right. I don't even have a...
Click on Show My Screen.
I don't even have that option.
All right, let me
Can
go
you
back.
give me...
I'm going to go back and do it again. I'm going to make you presenter all over again.
Okay. It's not a real big deal. I'm pretty much done.
All right.
Yeah.
Let's see. I think we're back to me. Let me try. I'm going to try to give it to you one more time, Kevin.
Yeah.
Sorry about this.
You know what, Kevin? Don't even worry about it. Oh, there we go.
Yep.
Kevin Corbley, were you able to see the last of this?
Yeah, it's back on now. The demo's back on now. I don't know what happened, but you're live again. Yep.
Okay, okay, fantastic. This really was the end of my presentation. Let me swap these around. So we're going to be releasing EdgeWise 5.0 mid to late April, and we'll be presenting it live at SPAR. I hope as many of you guys as can are going to be out there. SPAR is always a great show. We personally learn a ton from all of the different presenters, all the different exhibitors, etc. We're going to be at booth 429, and love to have, if anybody wants to see this work on some of your own data, bring it by and we'll process it for you live. And look forward to seeing hopefully a lot of you guys at SPAR. Back to you, Kevin.
Okay, terrific. Thanks, Kevin Williams. That was a great demo. And for those of you who have not been to SPAR in a couple of years, it is back in Houston, and I believe they are breaking records for both the number of exhibitors and registered attendees. So it's going to be a great show this year. And I believe, does it start next Monday, Kevin Williams?
Yes, it does.
Okay, great. All right, terrific. Well, that was great. Terrific demo. And now what I'm going to do is I'm going to ask Chris Nixon to come on, and Chris is going to show us really it's the first of our 2 case studies for today, and Chris is with Meridian 3D. And Chris, you should have control of the screen now. Go ahead, take it away.
All right, thank you very much. Yeah, thank you, Kevin. I'm going to go ahead and go to the next one, see if we can make sure it works. Great. So a little bit about Meridian 3D to start off, and I'll keep this very brief. But we were a standalone division of Meridian Associates just last year. Meridian had a long 10-year history in the scanning industry, and at the end of last year, the standalone division split off from the parent company, and I was fortunate enough to become the owner of Meridian 3D. So we've brought with us the team and our experience and the history and our clients from all of our projects completed for Meridian. And Meridian Associates is still completing projects in the Northeast region in the New England states and continue to be our strategic partner. We have our home office here in Greensboro, North Carolina, not too far from the ClearEdge folks, and we have a field office in the Houston area, and we service a lot of clients in Southern California. So the basic backgrounds of Meridian, we're in some ways you could be considered one of those MEP guys Kevin was talking about earlier, but we pretty much scan a bit of everything. We've done buildings, we've done museums, we've done small parts, we've done huge industrial facilities. So we've got a wide and varied array of things that we've scanned over the years, and it has turned into pretty much every industry, every size. But being one of the older companies doing this, we have our lumps on our head to prove it. We have some realistic and hard-learned approaches to our scope and schedule, and we try to be very fit for purpose and practical in our approach. We're very vendor neutral, but we're trying to give data, good quality data, and good quality models to everybody, because the more that we promote that quality, the more they accept that they're going to get a solution every time, the better the entire industry does. We all benefit from it. So it's one of our core principles around here, and we were very excited to see the developments from ClearEdge. So we had a project that came up right about the time we first heard about the new release, and this was a sort of a local site for us. We had just scanned a chemical plant facility that also is a clean room environment in some ways because it's in food processing. And we knew that they wanted an identical unit scanned somewhere down the road. So we got involved and said, hey, look, let's test out the new system, because we have a one-to-one comparison, a very good metric for comparing time on one job with another and what the result will be. So in this case, this is about a 1,400 square foot facility, 2-3 stories tall, with platforms and everything else. 1,500 cubic meters, 15,000 cubic meters for those on the other side of the pond that are joining us today. The Revit native model is what we need to produce because we tend to wind up with the Revit native model at some point. So we're going from native back to AutoCAD. Very difficult to go the other way, so we build everything in Revit. For this particular job, we had a very, very quick turnaround time. We had a short duration, but we managed to go from the very initial safety meeting to getting the job out the door and everything invoiced in 15 business days. So that's using our standard old workflow. So the first time we did it, we used that old workflow. The second time we repeated it with ClearEdge. All right, so make sure I didn't go one too far there. Yeah. So we're seeing here how congested the plant is. This is up on the third level in this case. And you can kind of get a detail for the value or how much we're trying to scan and what we're trying to get out of it. So our unique challenges on this site, very dense as you could see, but we also had like highly reflective stainless surfaces, and we needed to be, our guys had to be very switched on to making sure that we didn't get blowout on the laser return. We had a clean room environment with respirators. We had that short lead time, so we knew we needed to get the work fronts back up for the engineers for their quick turnaround. And then we warranty and underwrite our jobs, and we had done this for the client, so we've got that critical first-time fit. So for us, pretty much everything we approach, accuracy is paramount, as it is for many of you doing this. So this is, again, back on that level, looking towards the other side, and we're getting to see the complete model overlaid in our walkthroughs. So the way we go about it, fully targeted scans with no cloud registration, but we post-process with cloud improvement once we have everything targeted and a fit between the two precision instruments. We plan out all our positions, but then the field crew can optimize them on the fly, and they did a great job to eliminate shadows. The fundamental concept for us is that, you know, low noise, complete data leads to very fast modeling. That's where you save your time. Now, if the modeling is going to be automated, if the primary geometry is automated, it helps as well. I mean, that's sort of a core fundamental. The less time we have to spend determining ambiguity in the model, the faster that model is going to get out, whether it's our primary workflow or our new workflow. All right. Let the machine catch up here. Now, for us to cover that area, we needed 70 scans, so we accomplished that in 2 days. We use a 2-person crew, a scanner and a surveyor, working together, measuring the targets per scan as they go, and then all georeferencing is completed, and we have a registered survey file to check against our target file as soon as the guys hit the ground back in the office, so that we can turn this thing around and get it into the production side. So in our standardized workflow for the back office modeling, we're going to create the primary geometry using a discipline-specific approach. We have experts that look at it in certain ways. They create the geometry on their own layers. We have integrated QA, so QA is reviewing it as the modeling comes out, and then, which is a great way to do this, we do the virtual walkthroughs of geometry with our cloud. So we're bringing the models back in, we're walking them down, we're slicing them, as it's being created from the QA side. And we were very excited to see in ClearEdge, how effective some of those same virtual walkthroughs were already. And then what Kevin is showing today is I'm even more excited about. So the case study, we come away with an amalgamated model complete. We did a fairly high level of detail with the electrical and everything else, but for us this would be a medium level. So when we get into the trying to do it with ClearEdge, we repeated it the second time. We said, okay, we're going to run this through. How can we change, what's going to change our workflow? So for us, we replaced the primary geometry creation. So all the large components, and as you've seen and as we've known, the large components come in very easily. I didn't see Kevin's numbers earlier, but we had estimated a 3% false positive ratio, and I've got to agree with that. That's about what we saw too. There were very few false positives. And then we were able to complete our QA/QC walkthroughs, in other words, the virtual walkthroughs, while staying in EdgeWise. So that was very useful and very flexible for us. And then, of course, the native Revit families. We can get it straight out into Revit. We don't have to go in there and do a whole lot of extra work once we're completed with the extraction. So you can see here where we just ran a first run of piping to pull the primary geometry, and we captured a lot in the right space. And from the images, we're seeing that this was a very complete and true model. It was we're just ready to go and begin our process of connection. So for us, and in our office, Rick Artiga had tested the 2 previous releases, because we've always seen the value, but we could see that in our first review that we were falling over on data size a bit. As we got into the bigger type data sets that we were typically used to, we couldn't quite load enough. Our second review showed a lot more promises, but we had a lot of false positives, and that's exactly what Kevin was demonstrating earlier. But like we say, we're seeing a huge improvement, and we've gone ahead and purchased the software to get started, because we see this as changing our workflow for us. So, 3%. I don't know how we're ever going to get to how they're ever going to get to 100% with no false positives, but we're certainly seeing a great improvement. And any false positives that get out of the system is fantastic, and just cuts down on work later on. And then one of our biggest hiccups right now for us is we have to regenerate the databases to bring it into EdgeWise. But we know that, to get the native files in, you got a lot of collaboration, you got a lot of players that have to be involved in that, and that may be more of a business decision. But SPAR's coming up, so hopefully that gets discussed there as well. All right, and you can see just how much we were able to get out of the first run in that area. All right, so our final deliverable, the challenges for us were modeling that primary geometry from the original workflow. We have a lot of confidence. So for us to go into ClearEdge, we've got to say, okay, well, how many false positives do I have when we're first testing it out? So we had to spend a little time to really get accustomed to that. But we feel like once we know what to look for, and some of the reporting that Kevin was alluding to, it's going to really help us to determine where that is. So it's not QA/QC as we go quite so much anymore, but we're seeing that we won't need as much of that moving forward. And then we need to be able to adjust our scope. That may be just inexperience on our part, granted, but a lot of the small stuff that comes in right now, we just have to get out because it's below scope. So we don't want to, clients may have a reason for not modeling down to certain levels, besides cost. You know, they may only want a certain level of detail. So we need to be prepared for that when it happens. And then this image gives you a bit of the final view of what we can actually see once we're completed, and our absolute findings here. So 240 man-hours with the QA in our own workflow. So the first unit, we had 3 staff involved. We met the duration very handily, but when we repeated it using EdgeWise, because we went directly into primary geometry and then we went directly into QA, we actually only used 2 staff. So we're not, I don't think, massively cutting down the time in hours for us, which was not our goal in this, but this is so that we see that we can better leverage our assets. We can use our machines, our computers, and we can do more projects, and we can have our QA managers involved in getting multiple projects out the door, not just one for Tom. So we're seeing a real benefit in leveraging our new work and increased work. So on this particular project, we're able to complete a very nice amalgamated model in the end with all of our disciplines back in. Turned into a very nice turnaround for the client, and has brought us right back into not only modeling their second one, but on to the next one. So with that, I'll leave it off, and I'll give it back to you guys.
Okay, Chris. Hey, that was terrific. Really appreciate that. And just a quick reminder before I hand it over here to our next speaker, to the attendees, please feel free to send your questions in. We've already actually got quite a few questions, so get those in now, and we're going to try to get to as many as we can at the end. And right now, I'm going to ask Louis Boxer to come on. He's with Advanced 3D Laser Solutions, and he is going to be giving us another case study. So, Louis, I am making you the presenter. You're ready to go. I think you might be on mute, Louis.
There we go. Can you see my screen?
Yep, there you go. Perfect. Yep, we see your screen.
Fantastic. Well, good afternoon, everybody. My name is Louis Boxer. I'm the Technical Director of Advanced 3D Laser Solutions. Before I start our presentation, I'm just going to give a brief intro about our company, ALS. So most of the directors in ALS are actually have a background in process engineering, or in the applications of it. We have a background in surveying and drawing PNRDs, Desir drawings, isometrics, and general arrangement drawings for many different firms, including petrochemical, detergents, pharmaceutical, and the food and civil industry. We also have a background in surveying for compliance studies. That includes COMA, COSH, and Desir. We've also been using laser scanning for some other backgrounds as well, including heritage and the civil industry. If you take a look at our website, you'll be able to have a look at some of the case studies where we've been able to apply some of this laser scanning. Moving on. So about the project, so one of our clients who has 5 oil storage depots, each site typically consisted of 20 pumps, 10 road loading bays, 8 product tanks, 4 additive tanks, an ethanol tank, and a VIU unit, a vapor recovery unit. And what that client required was isometrics to be created of all the pipework on site to be used for NDT inspection, which is non-destructive testing. So what we proposed was to use laser scanning technology. The reason being was some of its benefits was that it was far faster than doing it the manual method of someone basically going out there with a tape measure. It was safer because it meant we'd have less teams out there walking around on their site. With the laser scanning technology, it meant that we wouldn't actually have to touch any of the site because the laser scanner obviously uses a laser. It'd be cheaper because of the time being spent out on site and the time spent creating the isometrics. It was green as well because obviously if someone was going out on site, they would have to print off all the isometrics. They would have to go out on site, pen those up, take them back, cut them up, possibly print them off again to get them checked. And the best thing about it wasn't prone to human errors. Obviously, if someone going out with a tape measure is going to make mistakes. Not always, but with laser scanning, we'll make mistakes. And when we come to register it, it'll actually tell us if we're out at all. We actually use mostly reference spheres out on these sites, mostly because the sphere can be scanned from 360 degrees. We've found that the checkable targets are limited to a certain amount of range, and you could only view them at a 45-degree angle, or no more than a 45-degree angle. We also proposed that we create orthographics for the client, as you can see at the bottom right of the screen. The reason for this was because we knew that doing this particular project that there was going to have about 500 isometrics, and with the orthographicals we were looking at near enough 50. Each site was split down into different products, for instance petrol, diesel, gas oil, Caro, and a couple of others. So what we did, instead of doing one line number per sheet like an isometric would be created, we was able to split down the site into logical areas like pipe slab, tank farm, road loading. And within that one sheet actually produce or show all the orthographicals, show all the lines on one orthographic sheet. This meant that when they're out on site, they'd only have to take one sheet out with them, and because it's geographical, they'd be able to find the lines straight away. And there's plenty of other benefits for using the orthographic drawings. So, the traditional surveying versus 3D laser solutions. The client had originally assumed using one surveyor, and that surveyor would have to be something like a piping designer or someone that at least knew what he was looking at. They reckon he'd be able to create roughly 2 isometrics a day. That's going out of site, surveying, coming back to the office, drawing them up and CAD them up, and possibly taking back out of site and checking what he's CADed. Each site, like I said earlier, there's 5 sites. Each site required about 500 isometrics. So we reckoned, or the client reckoned, that it would take about 250 days of work, and that was going to be over £50,000 per terminal to bring someone in and do this. Using the 3D laser scanning technology, obviously another benefit, obviously the accuracy was plus or minus 2 mil, was able to, each site we used about 200 scans. We completed this in about 4 to 5 days using 2 surveyors. Both surveyors actually came from a laser scanning background, or not laser scanning and an engineering background, which meant that they actually understood what was out on site, where they should be taking the scan positions to reduce scan noise and shadowing. The whole laser scanning side of the job was completed at a fraction of the cost of what the original traditional surveying would have cost the client. And the best bit about laser scanning always is that we was able to capture everything, all site data. And by that I mean, obviously we went in to scan the pipe work, but because of the laser scanner and how it works, it's able to collect absolutely everything. So there's enough data there for topographical data, still work data, building, civil, absolutely everything. So at the moment the client is only looking to use the data for the pipe work, but he's already asked us to look into modelling the still work and possibly topographical data. Okay, so the 3D modelling side of it. To create the isometrics, we was going to use, actually using the scan data, produce a 3D model using a point cloud recognition software. The client required that the finished product would be done in Autodesk Plant 3D. The reason being is because the client already uses Autodesk software and they're currently having some design work done at the moment, and they were hoping to use the 3D model that we created for them in the design work, using it for clash detection or for tie-in. So, using the point cloud recognition software, we first of all use a manual modeling software, a point sensing program. The first site that we used the manual point sensing program software was actually the smallest site. It took over 6 weeks just to do the modeling of the pipe work. ALS itself was actually exposed a lot of limitations of the software straight away. The software actually had to run within the Autodesk Plant 3D software as a plugin. We found that the software was incredibly slow and unstable. We actually found that the software would actually crash, like fatal crashes, and would lose our work through just random moments. We'd possibly panning through the point cloud, and all of a sudden we'd get a fatal error. We found the software incredibly slow as well. You'd have to model out single sections of pipework, individually putting a flange, for instance, and then put the valve to put it up against it, and then another flange, and then another piece of pipework. The software had a lot of limitations. It struggled with laser scanning noise, and obviously scanning on brownfield sites, you're getting a lot of dust in the air. There might be water, surface water on the ground, which would obviously cause noise in the laser scanning file. Because of that, the software was actually really struggling to model out simple runs of pipework because of the noise. The second limitation was pipework lag, and a lot of you must understand that some of this pipework has been outside for a lot of years. Because of the 4 seasons, obviously, the pipework goes through hot and cold periods, and because of it, it moves back and forward, and because of weight, obviously, with the product being through it, and the heat of the product going through it. So long story short, the pipework moves, hence pipe supports. And the software was struggling to understand that. The software would also model it out as a brownfield site, but at some point it would have to go through a constraint, a tolerance, and actually have a look at applying these 90 degrees and the valves in against the tolerance. And as soon as it did that, it tried to push it into a greenfield state. And because of that, it was causing the software to crash. It was kicking components out. For instance, if we look at the picture at the bottom right, you can see the pipe in pink. You can notice the point cloud. There's a single pipe support here which caused the pipework on site to actually lag. Imagine this almost bone effect. And when we came to model it out using the point sensing program, it's just struggling with it. Also, we was noticing, well, didn't notice, but we had to pay out a costly fee for software training to actually be able to use the software. Okay, moving on. The automatic modeling with EdgeWise 5.0. The first site we used was the second site, which was actually the largest site. It took under 6 weeks to model compared to the 6 weeks of the smallest site. So straight away there was a significant saving there. The program was incredibly fast and stable. With the manual modeling program, we was only able to run small sections of point cloud data. We're talking under a gigabyte of scan data. With EdgeWise 5.0, was able to run, for instance, for the largest site, the whole 60 gigs worth of scan data and put that straight in. And because of its automated procedure, it was able to find the pipeline. We didn't want to obviously bring in just a gig at a size. So it was great to hear that it would be able to take the whole 60 gig. The biggest benefit was the ability for it to understand the brownfield environment. Like I was saying earlier, that the manual software was struggling. It was kicking components out. It wasn't lining up with the point cloud data once you applied the tolerance. But with EdgeWise, as soon as we applied the tolerance, it would actually apply a break in the pipework. And what this meant was that obviously once we'd export it to Plant 3D, which I'll talk about later, is that Plant 3D still only understands straight bits of pipework. So these breaks allowed the pipework to stay within the brownfield point cloud data, but also be useful within the Plant 3D file format. Against the modelling, the manual modelling, we did notice a huge, it was a lot faster modelling, basically. Obviously, a lot of it was automated. We had experience using the EdgeWise 4.0 software, which didn't have this, the benefits of the 5.0 software. But because of the database that it applies, it allowed us to easily delete out a lot of false positives incredibly quickly. And with their tools, we was able to delete out a lot of stuff, a lot of false positives incredibly quickly. And because some of these sites had nearly 9,000 pieces of pipework, that's obviously individual pipe runs, not just the whole line numbers. The software was also a lot cheaper to run because we didn't have to also hire out Plant 3D to be used as an add-on for the manual modelling software. So it actually run on its own software. Also, it was free training. We had a lot of online videos that allowed us to learn the software quickly, and a lot of phone support allowed us to ring them up and well, actually rang us to check to see if that was using the software at its full potential. What you can see here is the point cloud data and the orange pipework. This is all done within EdgeWise and what you're looking at. The black bits you can see between the orange runs are connections between what you could find. So obviously when you run the point cloud into the software, it looks for possible pipe runs. And the second phase you go through is that you obviously delete out all the false positives, and then you ask it to look for possible connections, and that's what you are looking at here. There's all these connections saying that this obviously pipe run is actually connected to this. And then we go into connecting pipe runs with elbows and T's, and that's what you can see obviously around here. So what you can see actually is what you're looking at is a pipe track here, and you're going up into a pipe bridge that's actually going into a road line area. Again, this particular site was about 40 gigs worth of data, so a heck of a lot of data, but it didn't struggle with it at all. We didn't have any software crashes, so I was incredibly pleased, and it was just pleased with how quickly it could turn around. So the ClearEdge is Autodesk Plant 3D plugin. We was able to work with ClearEdge with the beta program and test it and get to have a look at how they're using the data and how they're building the program and putting a bit of how we'd expect to use it and what we'd like to see with the program and give a bit of input. We found that the Plant 3D, obviously you have to export from the ClearEdge software into a .pcf file format, which is a tiny file. It's about, I think for one of the sites, I think tops it was about 2 megabytes. And from that, you open up your Plant 3D software, run the plugin, the ClearEdge plugin, and import the PCF file format. And from there, it takes about anything between 5 to 10 minutes to import the whole site. We found that the data that it imported across into Plant 3D was obviously fast to import. 5-10 minutes is not very long at all compared to the manual software, and it was incredibly accurate. We imported the point cloud data to match it up against, and it was still incredibly accurate against the point cloud data. We actually only imported pipework across, from ClearEdge. We didn't actually model in any valves or flanges. The reason being was because we was using some specialist components for the site, and the Autodesk Plant 3D software was incredibly fast to actually model in the valves and flanges and whatnot. So we decided just to import the pipework across and add the components in after. We found that a couple of pipework runs didn't come across. Compared to what I said earlier, about 9,000 runs of pipework we imported. And we noticed possibly 4 or 5 pieces of pipework didn't import across. And what they actually leave behind is actually a small block reference file. So you can actually see where it missed out a bit of pipework. Also, there was a few drips to be cleared up. Again, we spent about a day, possibly 2 days, clearing out the drips, but it was a very fast process. And a lot of that, again, was because of what I was explaining earlier, was the ClearEdge would actually put a break into the pipework. I think it's about a 10 mil tolerance to make sure that it stays within that point cloud data, which is what we want, because we're still trying to model out a brownfield site here. It's not a greenfield site. It's not using perfectly straight pieces of pipework. And so yes, so some of the drips was because of that. But like I said earlier, it was incredibly fast, and we was able to do that incredibly quickly. So the conclusion, the manual modelling software resulted in a huge loss of time and money for us. And we wasn't able to, well, we envisaged that we wouldn't be able to complete the project within the time that we allocate using the manual software. Using the ClearEdge software, unfortunately we couldn't, I'd like to bring up, we didn't actually use the ClearEdge software straight away. We obviously used the manual modelling software first because it was able to export into Plant 3D, and at the time ClearEdge's software couldn't. We didn't, at the time, obviously ClearEdge could and still can export to PDMS, but we didn't want to use the huge cost of using PDMS, and our particular client at the time wanted to use Plant 3D software. So using the ClearEdge software was allowed to, well, it allowed us to quickly and accurately re-establish our project. We was able to quickly get on top of the other 4 sites and export them into Plant 3D, so it allowed our on-site modelers to begin adding valves and begin line numbering. But long story short, the EdgeWise software, the EdgeWise 5.0 software, saved us about 60% versus our old workflow. Like I said earlier, the manual software took about 6 weeks to model out the smallest site, and the EdgeWise software we did within 2 weeks. So I think I've covered everything. I'll put some details down there. Obviously, take a look at our website, and we've got a few case studies on there so you can have a look at. And if you've got any other details, give us an email or phone call. Okay, I think that's me.
Terrific, Lewis. Appreciate that. Great presentation. And we're running a little over, so we're going to move pretty quickly into the Q&A. All right. And it is Q&A time. We do have a lot of questions. And here we go. Then let me move into the questions pretty quickly. So I'll ask the presenters to turn their mics back on. And let's see. There's a lot for Kevin Williams. Kevin, here's the first one. It says, what's the maximum accuracy we can achieve with the steel extraction? Many of our clients are looking for 1/8 inch accuracy, and they want beam deflection followed in the model. Is EdgeWise capable of this accuracy?
Yeah, thank you. So the software is really only going to be as accurate as the point cloud is kind of the first point. I've very few people. We have a handful of customers who we've seen scans that are registered to within an 1/8 inch, but most people are fooling themselves if they think they can get that type of accuracy. Just to be realistic, the scan data itself, typically once it goes through the registration process, is not that accurate. As far as the fit, it's going to be the best fit to the point cloud, but it does not follow beam deflection yet. That's something we're contemplating for a future release, but the software will be a best fit, or it does a best fit to the point cloud with a straight idealized piece of steel.
Okay, sounds good. And Louis, this one's for you. What modeling software did you use in your old workflow?
We still, I'm not sure if I'm going to be bringing up the manual software. Am I allowed to do that?
I think it's okay. Kevin Williams, you okay with it?
I'd probably not.
Okay, all right.
Also, if anyone's got any questions, give me a call, and I don't mind maybe talking to them about a few bits. But we still use Part 3D as the end product, but yeah, obviously I can't talk about the.
Okay, fair enough. Okay, and Kevin Williams, does Revit recognize those elbows as Revit family objects?
Yes, absolutely. It's as if you had just modeled it inside of Revit.
Oh, good. Okay. All right, Chris Nixon, were the tanks and equipment just shown extracted by EdgeWise? That's referring back to your case study.
The cylinder portion of that equipment was, and then if we had to go back and add a cone or surface, we would do that as part of the manual cleanup afterwards.
Okay. All right. And Kevin Williams, does EdgeWise support cleaning point cloud noises automatically or manually deleting portions of point cloud data?
No, the current version of the software, that's definitely something that we're going to be working on in the future. The current version of the software is really for getting a CAD model out of the point cloud. So it leaves the point cloud as is. You can change the display of it, but it leaves the point cloud as is and just extracts pieces. So any of the editing you do is going to be editing the steel or the pipes or ducting or whatever you're modeling.
Okay. And Kevin, this one's for you too. What's the approximate utilization rate compared to Revit? If a project takes 250 hours to complete, how many hours do you spend on post-processing the model in Revit?
It's entirely project dependent. So the ideal workflow these days, what most people are finding is you want to do as much modeling as you can within EdgeWise, because it's just a whole lot. EdgeWise is designed to work with point clouds. Revit is not. Revit's designed for greenfield work. And so you want to do all of your editing inside of EdgeWise and then export that model, but there's always going to be other components that we don't model. We don't model everything that Revit does inside of EdgeWise. And so, you know, if you're modeling buildings with light switches, lights, things like that don't come out of the EdgeWise model, you've got to go in and do all of those. So it's entirely project dependent.
Okay. And Kevin, if there's a deflection in the steel or the camber did not fall out, will it model as is in the field, or is it per model library?
Again, it's not the software is only fitting straight cross sections or straight pieces of steel, and it's going to fit that idealized straight piece to the point cloud. Best fit to the point cloud, but it's not going to model the camber of a piece of steel.
Okay. All right. And I don't know if you covered this or not, Kevin. Somebody asked here, how's the project or progress coming on the CADWorks export from EdgeWise? Will it be coming out of beta with the new 5.0?
It's still beta, but there have been some significant improvements to that section of it. So the CADWorks is really, it's pretty far along, but it's still technically in beta in the 5.0 release.
Okay, and these questions just keep coming for you, Kevin. Do you have any module or add-in or step conversion so that the 3D models can be imported or opened in CATIA version 5? Does that sound right?
CATIA, yeah.
CATIA, sorry about that.
No, unfortunately. Yeah, it's a no, not yet. We've had a number of people ask for that. We have a fairly lengthy to-do list.
Okay.
I apologize. That still has not been built.
All right. Okay, let's see. Kevin, again for you, does the new pipe extraction feature negatively affect pipe fitting when there are limited scan points to work with, like above ceiling scans or pipes that are high overhead?
No, it's better than it used to be. So you're going to get better quality results. Even with low point count, it's still, you may not get an extraction if you have too few points, but it's going to be at least as good as the old version, and in most cases better.
Okay, and we're just going to take 2 or 3 more real quick ones here. Kevin, does setting scanner density higher limit false positives and help clear edge extractions work easier?
Yes, to a degree. Really the more important thing is to get better coverage though. Density, you need a kind of a minimum density for a pipe, but if you can get both sides of the pipe, that's more valuable than scanning the heck out of one side of that pipe.
Okay, and is there any way currently to extract cable trays?
We've got we can fake it. That's on the hopefully the near term to-do list. We've got a tool right now for extracting ducting, and ducting is typically modeled pretty much identically to cable trays. The same basic geometry is there, and so you can extract it as a duct and export the geometry that way. But we don't have a cable tray specific tool yet.
Okay. Great. Let's make this the last question here. Kevin, again for you, does the new version take insulation of pipe duct into consideration so that pipe sizes are modeled more accurately? The way the software approaches insulated pipes is it's expecting human input at that stage. So you can interact with the smart sheet behind the pipes and input the insulation thickness. But it requires human intelligence at that point because the software has no idea whether a pipe is insulated or not unless a person tells it so. Okay, great. Well, I think that's going to be the final word. Again, we appreciate everybody joining us in the audience today. We are out of time, and so on behalf of our panelists and sponsors, Workflow 4.0 and ClearEdge, I want to thank everybody, including our panelists, and a reminder, you will be receiving an email after the broadcast with a link to the recording. There'll be a chance to subscribe to the Workflow 4.0 newsletter, and there'll be other follow-up information, and we hope to see you again for our next webinar. Thanks for joining us.